Fraction to decimal equivalence, meeting the requirements for TEKS 64G. Fractions and decimals represent numerical values, and they can be made to represent equivalent or the same numerical values. Now, here's what I mean by that. I might have the fraction 2/5. 2/5 is a fractional representation of a numerical value. I can take that fraction and represent it in the form of a decimal that has an equivalent value. I know, for example, that the decimal 0.4 has exactly the same value as the fraction 2/5. And today's lesson, we're going to talk about how I can take a fraction like 2/5 and turn it into or rewrite it as an equivalent decimal. Now, at this point, you might be asking the question, why? Why do I need to know that a fraction, say like 3/5, can be rewritten as a decimal of an equivalent value? Well, the first reason why would be to make comparisons. If I told you that I had 3/5 of a dollar and we knew that you had 65 cents, which one of us has more money? Do we know? We certainly can't be sure, because right now my dollar value is represented as a fraction, while yours is represented as a decimal. So to make easier comparisons between two numerical values, it would be much easier if they were both written in the same form. So rewriting that fraction as a decimal would then give me two decimals I could compare to each other, and that would be very helpful. Another reason would be to perform operations. If I want to add, subtract, multiply, or divide, if I have a fraction and a decimal, I won't be able to do those operations. So I need to rewrite my fraction as a decimal so that I can perform operations. So for comparisons and for operations, it's necessary we understand how to rewrite fractions as decimals. So one person has 3/5 of a dollar, while the other one has 65 cents. And we want to know who has more money or who has less. So we're going to rewrite our fraction as a decimal, so we can more easily make a direct comparison between these two values. How do I rewrite a fraction as a decimal? I simply do what it tells me to. We know that a fraction is a division problem, so that's what we're going to do. We're going to divide our numerator of 3 by our denominator of 5. We know the denominator always stays outside. 3 divided by 5. Now, how many times can I subtract 5 from 3? Or how many groups of 5 can I make from 3? And I think we agree the answer to that is 0. I can't make any groups. 5 times 0 is 0. 3 minus 0 is 3. When I compare, 3 is less than 5. That's excellent. Now, we have no additional digits to bring down. We have a remainder. So let's add a decimal to our dividend and push it to the top of the house. And then add a 0. And bring down that 0 to allow us to continue. Now, how many times can I subtract 5 from 30, or how many groups of 5 can I make from 30? And it appears the answer is 6. 6 times 5 is 30, and when I subtract 30 from 30, I get 0. I have 0 as a remainder, which is less than 5, and I have no more numbers to bring down. I'm finished. So, my decimal equivalent to the fraction 3/5 is the same or equivalent to the decimal 0.6. Now, I have 0.6 and I have 0.65. Which decimal is larger? Well, I think, if you remember, the absence of a value is 0. So, is there a digit or number that follows the 6 in 0.6? There certainly could be, and it should be 0. 0.6 or 6/10 is exactly the same value as 0.60 or 60/100. And by placing that 0, I can more easily make a direct comparison between these two decimals. So, which person has more money? The person who had 3/5 of a dollar, or what appears to be 60 cents, or the person who had 65 cents? And I think we'd agree 65 cents is larger. So making a direct comparison is certainly one good reason to be able to rewrite fractions as decimals. You saw how much easier it was to tell who had the most money. But what if I were also looking to do something like this? What's 3/5 plus 0.65? How would I even do this operation? I have a fraction, which is a value written in one form, and a decimal, which is a value written in a totally different form. I need these two to be written in the same form so that they can, in this case, be added. Now remember, we found that 3/5 was the decimal equivalent, or the fraction equivalent, to the decimal 0.6. So could we add these two decimals? I think the answer to that question is absolutely yes. 0.65 plus 0.6. And now remember, the absence of that value meant that this was a 0. There was a 0 in the hundredths place. So when we add these, we get 5, 6 and 6 is 12, 0, 0, 1 is 1. Don't forget our decimal, which when we add or subtract decimals, those decimals need to be lined up. So if I added the 60 cents that one person had and the 65 cents the other person had, we find that together they had $1.25. Very easy to see when they're written in the same form. But up here, where we saw 3/5 of a dollar plus 65 cents, could we have known immediately that that was going to make $1.25? I'm not so sure. So now I have the fraction 2/3, and I want to rewrite it as a decimal. Well, earlier I told you, divide the numerator, so 2, by the denominator of 3. 2 divided by 3. Now, how many groups of 3 can I make from 2? Or how many times can I subtract 3 from 2? And I think the answer is 0. 3 times 0 is 0. 2 minus 0 is 2. 2 is less than 3, so that's good. I have no digits to bring down, and I have a remainder. So that means I need to add a decimal to my dividend and then push it to the top of the house. And then add a 0 after that decimal. And I'm now going to bring that 0 down. How many groups of 3 can I make from 20? Or how many times can I subtract 3 from 20? And it looks like the answer to that question will be 6. 6 times 3 is 18. 20 minus 18 is 2. 2 is less than 3, so that's good. I don't want a remainder, so I'm going to add another 0. So I can then bring that down. How many groups of 3 can I make from 20? Or how many times can I subtract 3 from 20? And just a second ago, we said the answer to that was 6. 6 times 3 is 18. 20 minus 18 is 2. 2 is less than 3. We have a remainder and we don't want one. We're going to add another 0 so that now we can bring that 0 down. Wait a minute. So we have 20 again. We had 20 here, and now we've got it again here. How many groups of 3 can we make from 20? Well, it looks like it's going to be 6 again. And we're going to continue to get a remainder of 2, each time bringing down the 0 to have that remainder of 20. So we're going to continue to get 6 in our quotient. So when I have a number that repeats over and over and over again, here's how I write that decimal. 0.6. And if all I have is 6 going on and on and on and on, I write a repeating bar over the 6. So the fraction 2/3 can be written as an equivalent decimal of 0.6 repeating. Now let's take a look at an example of a mixed number. Now we've been looking at fraction to decimal equivalents, where I've been rewriting the fraction as a decimal. So if I have a mixed number, the first thing I'm going to do is to take the whole number and set it to the side. I don't want to forget it. It needs to be included, but it doesn't need to be rewritten. I'm not going to be dividing the mixed number like I am the fraction. And now I simply divide the fraction as we've been showing all along. And when I divide this fraction, I find that I can make no groups of 4, that when I subtract 0 from 1, I have 1. When I compare, I'm less, so I'm good. I need to now put a decimal in the dividend, push it to the top of the house, add a 0, which I'm now going to bring down. I can make 2 groups of 4 out of 10, or I can subtract 4 twice from 10, because 4 times 2 is 8. 2 is less than 4. That's excellent. I have a remainder. I don't want one. So I need to continue to add numbers, zeros in this case, to the end of my dividend so that I continue to have something to bring down. I can make 5 groups of 4, or I can subtract 4 5 times from 20, because 4 times 5 is 20, and 20 minus 20 is 0. I now have no remainder and no digits to bring down, so we're finished. My decimal equivalent to 1/4 is 0.25, or just 0.25. I now take this decimal and add it to the end of my whole number, remembering that I had the 3 wholes the entire time. So therefore, my mixed number of 3 1/4, or 3 1/4, is equivalent to my decimal of 3.25, or 3 25/100. Let's now wrap up the lesson. There were really 3 main points. First, to convert a fraction to a decimal, I need to divide the numerator by the denominator. Second, if I get a decimal that repeats, say for example something that looks like this, then once I realize it's repeating, I should stop. Write the value with a repeating bar above it. Finally, if I have a mixed number, say I have something that looks like this, I need to make sure I include the whole number in my final decimal response so that I don't inadvertently put only the decimal value without including the whole number.